Question A. In the photoelectric effect, electrons are emitted from a metal surface almost immediately after light is incident on the surface, i.e. without any time delay. Explain this observation with reference to Einstein's theory of the photoelectric effect. So you need to state what that is. So Einstein said that light consists of photons, where E is equal to hf. Each photon has an energy equal to Planck's constant times its frequency. And there is an instantaneous, when the light hits the surface, there is an instantaneous transfer of energy from the photon to the electron, which means that electrons can immediately jump out of the metal surface and they will be emitted immediately. In B, it says the graph shows the variation with incident light frequency f of the maximum kinetic energy Ek of the emitted electrons. So here we have the energy. This notice is 10 to the minus 19, and this is times 10 to the 15. We have those multipliers, which one mustn't forget to use. So use the graph. So you have to use values from your graph to do these next two questions. Estimate the work function of the metal surface. Now the work function is always given where this line over here, under these circumstances, where this line intersects the vertical axis. So I'm going to draw that in. It's going to go through that point over there, so something like this. And when you have a look here, you see that this is 1.6 times 10 to the negative 19 joules. So that's the work function. Basically, you need that amount of energy to emit the electron from the metal surface. That's the minimum amount of energy that is required. And then anything over than that will be given as kinetic energy. So this will be 1.6 times 10 to the negative 19 joules. Then it says calculate the maximum speed of the emitted electron for incident light of frequency 5 times 10 to the 15. So 5 times 10 to the 15 is there. So if we go up here, we see that this is about there. It's the kinetic energy, the Ek, is equal to 1.7 times 10 to the negative 19 joules. Now that's a kinetic energy, and we know our kinetic energy formula is a half mv squared is equal to the kinetic energy, so that's equal to 1.7 times 10 to the negative 19. We want to know the velocity. We want to calculate the maximum speed. So we're going to have, therefore, v squared is going to equal 2 times 1.7 times 10 to the negative 19. And we're going to divide that by the mass. So that we're looking at the mass of an electron, which is 9.11 times 10 to the negative 31. And when we find we can find the square root of that to get what the V is. So I'm going to put that into our calculators, and when you do, you should get a V is equal to about 6.1 times 10 to the 5 meters per second. That's the value that should come out there when you put that into your calculator.